projectile, and we are looking into the approximation of the velocity and the initial angle. Okay, so Vfx is equal to Vix plus At, as a final velocity is equal to initial velocity plus acceleration into time. So Vfx is equal to V naught cos theta plus 0t, which means 0 here. Okay, 0t because the horizontal acceleration is negligible, basically 0. And here's the projectile motion, basically x-axis, y-axis, angle theta, x component of velocity, y component of y component of velocity, and velocity here basically. So Vx in general, on x-axis, it's V naught cos theta. V naught is the initial velocity. V Fy is equal to V naught sine theta. Now we're considering the uh, incorporating the vertical aspect plus Ayt. Vyi plus Ayt, the acceleration in the vertical direction, or V y is equal to V naught sine theta, the initial component, minus g, the acceleration due to gravity, dot t, the time of flight. Okay, acceleration is negative because it is being retarded by gravity. So we have this form, the second one, the first one here and the second one here. And from the Pythagoras theorem, we know that v is equal to Vy square plus Vx square under the root. Yes, so V is equal to V naught sine theta, V naught sine theta minus gt whole square plus V naught cos theta whole square under the root. Yes, so this is the form here. We can expand it as well, but it's not going to do much good in this situation. Now we look into the angle. Which says that tangent of theta is equal to Vy by Vx, which means that tangent of theta, it says v naught sine theta minus gt by v naught cos theta. Yes, so theta in this case is tangent inverse of v naught sine theta minus gt by v naught cos of theta. Okay, so this is another form. If we are looking to expand the velocity form, for example, v is equal to vx square plus vy square under the root, and v is equal to v naught cos theta whole square plus v naught sine theta minus gt whole square under the root. It says v naught square cos square theta plus v naught square sine square theta plus g square t square minus 2gt v naught sine theta under the root, and v is equal to v naught square cos square theta plus sine square theta here plus gt whole square minus 2gt v naught sine theta under the root. Yes, okay, let's make it more visible. Yes, so v is equal to v naught, and sine square theta plus cos square theta is equal to 1. So we're left with v naught square plus g square t square minus 2gt v naught sine theta. Okay, so this is a little bit of the mathematical expansion of the velocity form. V is equal to v naught square plus gt square minus 2gt v naught sine theta. Okay, so projectile, and we have this velocity x, and we have this velocity y, and we have velocity here, and here's the angle, and here we have this height in the middle somewhere. We have this maximum height. So for height, we look into the equation of motion to ay sy is equal to bfy square minus bi by square. On the y-axis, the acceleration and displacement, and the final initial velocity squared. Okay, which gives us 2 into minus g into h, which is the height, and we have square. Basically, on the maximum height in the middle, it has vertical component nearing 0, which means 0 square minus v naught sine theta whole square, the vertical component initially. So minus 2gh is equal to minus v naught square sine square theta. So h is equal to v naught square sine square theta by 2g. So this is a form here. Okay. So 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 here we estimated the height, and now we're interested in estimating the time of flight for projectile. So for this case, sy is equal to, the vertical displacement is equal to bi by t, initial velocity times time, plus half a by t square. So vertically, basically the net distance covered is 0 because it lands on the surface in the end. And so v0 is equal to v naught sine theta times t plus half, and now the acceleration due to gravity in this case is minus g, basically from the start to the end, minus g dot t square. So 0 is equal to rather gt square by 2 gt square by 2 is equal to b naught sine theta dot t. Now t is equal to 2v naught sine theta by g, and one t cancels out with the next on the other side of the equation. So this is the form we have for the time of flight of the projectile. Time to peak, no wonder it's the half of the time, the total time. So time to peak is equal to t by 2 is equal to 2 which is equal to 2v naught sine theta by 2g. 2 cancels out, so time to peak is equal to 2 v is equal to, excuse me, v naught sine theta by g. So this is another form if somebody is interested in the peak time. And there's range, maybe also the maximum range, but basically range of the projectile is what is important. Excuse me for the deletion part, the prolonged one. So now we have the range of projectile, which is Sx and x and y and theta in v. So this is very much the range. It can also be here it can be somewhere in the middle. It can be r, and till the end it is r max, the maximum range, when the angle is optimal. Okay, so the equation of motion, the horizontal distance Sx is equal to Vixt plus half Axt square. Okay, so r is equal to b naught cos theta t, b naught cos theta t plus half, basically the horizontal acceleration is 0, so plus half t squared dot 0, which is ultimately 0 for the second term. So what we have here is r is equal to v naught cos theta t, and since we have the value of t from the previous knowledge, which is t is equal to 2v naught sine theta by g. So for r we put this value of t, which makes it v naught cos theta dot 2v naught sine theta by g. Okay, so what we get is v naught square dot 2 dot sine theta dot cos theta by g. Okay, so this is interesting because sine 2 sine theta cos theta in trigonometry is equal to sine 2 theta, which is a substitution, and we can use it in the value for r, which gives us v naught square dot sine 2 theta by g. So for r max, now the maximum range is very obvious. Sine 2 theta has to be maximum, which is 1. R max is equal to v naught square by g. Okay, which means that sine 2 theta is equal to 1, and 2 theta is basically 90 degrees, and theta is equal to 45 degrees. Okay, so basically this is the form here, and this is the altered version. Yes, so we will not stop here. For mechanics, we'll go further into work, power, and more stuff. So we look into the work done.